Between South America and Antarctica lies the notorious Drake Passage, one of the most turbulent and dangerous regions of the oceans. Located at the southernmost tip of the world, this passage marks the meeting point of the Atlantic, Pacific, and Southern Oceans, allowing currents and winds to circulate freely around the globe without any landmass to slow them down. This phenomenon creates conditions that make the waters of the Drake Passage extremely rough, with waves reaching up to 20 meters in height during severe storms. The ice layer covering Antarctica is, on average, more than 2 kilometers thick, from the surface to the base of the continent. However, in its deepest points, the ice can reach nearly 5 kilometers in thickness, which is equivalent to 6 times the height of the Burj Khalifa, the tallest building in the world, stacked on top of each other. This means that 61% of all the Earth's fresh water is stored in this ice layer. If all this ice were to melt, sea levels would rise by about 60 meters, causing catastrophic impacts for coastal regions around the world. The Antarctic ice layer is so thick and inaccessible that many believe we have more knowledge about the surface of distant planets, like Mars, than about what lies beneath the ice on the Antarctic continent. Instead of drilling through kilometers of ice to explore what lies below, the primary technique developed to visualize the continent's subsurface involves the use of radio waves, which are sent through the ice and analyzed as they return, in a process known as radar sounding. However, the Antarctic continent is vast, significantly larger than Europe itself. Therefore, mapping the entire Antarctica using this technique would be an extremely challenging, costly, and time-consuming task. To date, we have only a limited understanding of what lies beneath the massive ice layer, based on a few radar-sounding flights conducted so far. It is estimated that over 90% of what lies under the Antarctic ice remains unexplored and unknown. Nevertheless, the few insights we have gained about what is beneath the planet's largest ice sheet on one of the world's most enigmatic continents have already revealed quite fascinating discoveries. Antarctica is undoubtedly the most enigmatic and least understood continent on the planet in the 21st century. Many people still lack a clear understanding of the true size or exact shape of Antarctica, which is compounded by the distorted representation we see on two-dimensional maps, where it appears as an irregular blotch at the bottom. In reality, Antarctica is the 5th largest continent, surpassing Australia and Europe in size and approaching the extent of South America. The true scale of Antarctica becomes apparent when compared to more familiar continents, such as North America. Antarctica is significantly larger than the 48 contiguous states of the United States, and the distance from the Antarctic Peninsula to the farthest point of the continent is comparable to the distance from the Canadian Arctic Islands to Mexico. If superimposed over Europe, Antarctica would stretch from northern Norway and Finland to Iran and Iraq in the southeast, and extend beyond Ireland in the Atlantic to the west. It is an immense place, almost entirely uninhabited and devoid of human life. The human population in Antarctica varies significantly, reaching around 4,000 people during the warmer months of the Antarctic summer and dropping to just 1,000 during the long, dark, and extremely cold winters, when darkness envelopes the entire continent for months and temperatures fall below -34 degrees Celsius in many areas. However, it's not just the severe climate that keeps the population low. Antarctica is also one of the most remote and inaccessible places on the planet. Located at the southernmost point of the globe, the nearest large human settlement is Ushuaia in southern Argentina, which is still about 1,000 kilometers from the tip of the Antarctic Peninsula. Despite this proximity, Antarctica remains incredibly intriguing. We know that the continent is not a unified landmass beneath the ice, as it might appear at first glance. If the entire ice sheet were to melt or be removed, the true shape of the Antarctic continent would be revealed. The Antarctic Peninsula, which currently appears as a solid land extension, would actually emerge as an archipelago of mountainous islands, often referred to as Lesser Antarctica. While most of the continent, known as Greater Antarctica, would remain above sea level and be roughly the same size as Australia, Lesser Antarctica composed of archipelagos, would stand out due to its distinct geological features and separate histories. The Greater Antarctica region, or the eastern side of the continent, is known for its ancient igneous and metamorphic rocks, while Lesser Antarctica, which is younger and consists of islands, is made up of sedimentary and volcanic rocks. Interestingly, Lesser Antarctica is part of the Pacific Ring of Fire, a continuous zone of tectonic faults and active volcanoes that encircles almost the entire perimeter of the Pacific Ocean and has existed for about 35 million years. As a result, most of the islands and archipelagos in Lesser Antarctica are of volcanic origin, despite being covered by ice and glaciers. A notable example is Mount Erebus, located at the far eastern end of Antarctica. It is the highest active volcano on the continent and the southernmost in the world, featuring a lava lake in its crater that has been visible since the 1970s, with its most recent eruption occurring in 2020. Most of the animal DNA traces found in the caves beneath Mount Erebus resemble known surface species, but not all do. Some of these traces could not be linked to cataloged species, but showed similarities to arthropods such as shrimp, centipedes, or spiders. This suggests that there may be arthropod-like species living in these heated caves beneath Mount Erebus that are still unknown to science. Additionally, there are 15 other active or semi-active volcanoes in Antarctica that could have similar tunnels and caves formed by hot steam, indicating the potential presence of more than a dozen subterranean ecosystems resembling oases hidden beneath the Antarctic ice, about which we know very little. Aerial surveys over Antarctica equipped with radar sounding have revealed a vast landscape beneath the ice, composed of undulating valleys, riverbeds, and hills, resembling topography found elsewhere in the world, but frozen in time and trapped beneath miles of ice. This constitutes one of the most fascinating geographical features of the continent. In 2019, an astounding discovery was made: the deepest canyon on Earth, located beneath the ice in Antarctica. Hidden under the Denman Glacier, this canyon plunges an incredible 3.5 kilometers below sea level, making it remarkably deep. For perspective, this depth is similar to the average depth of the Atlantic Ocean and about half the height of Mount Everest, the tallest point on Earth above sea level. In comparison, the lowest exposed point on Earth's surface is the Dead Sea margin, at 413 meters below sea level. The Antarctic Canyon is nearly 8.5 times deeper than this. Until 2019, the existence of this extreme canyon was unknown due to the ice that concealed it. Imagining this canyon without the ice is truly fascinating. However, the canyon is not the only intriguing geographical feature of the frozen continent. The ice in Antarctica hides many other impressive formations. In 1958, a team of Soviet researchers in Antarctica made an impressive discovery. They found a vast mountain range hidden beneath the ice, later named the Gamburtsev Mountains in honor of Soviet geophysicist Grigory Gamburtsev. This mountain range is comparable in length and height to the European Alps, stretching about 1,000 kilometers, with peaks reaching up to 2,700 meters. These mountains remain completely obscured from view due to more than 600 meters of ice and snow covering them. But Antarctica has more to offer. In the late 1950s and early 1960s, scientists began to detect a significant gravitational anomaly in eastern Antarctica. In this region, gravity was unexpectedly lower than anticipated, extending over approximately 243 kilometers in width and plunging to about 848 meters deep beneath the ice layer. For decades, various theories have emerged regarding the source of the lower gravity in eastern Antarctica. In 2006, a team from Ohio State University, using satellite data from NASA and the German Aerospace Center, identified what they believed to be an ancient impact crater with a diameter of 480 kilometers, hidden beneath the ice. However, due to the extremely remote location and the depth of the ice, no direct samples from the area have been collected to verify this hypothesis. Thus, the idea that an asteroid may have collided with Antarctica and created a vast crater remains a theory. though a compelling one. If the gravitational anomaly is indeed confirmed as an impact crater, it would be the largest ever discovered on the planet, with a diameter nearly 3 times greater than that of the Chicxulub crater in the Yucatan Peninsula, Mexico. The Chicxulub crater, formed by an asteroid approximately 10 kilometers in diameter about 66 million years ago, is widely linked to the extinction of the dinosaurs. To create an impact crater in Antarctica nearly 3 times larger than Chicxulub, the asteroid responsible would have to be between 4 and 5 times larger than the one that caused the dinosaur extinction, which would mean approximately 40 to 50 kilometers in diameter. Over time, phenomena such as erosion cause impact craters on Earth's surface to gradually disappear. Ohio State University determined that the structure hidden under the Antarctic ice is indeed an impact crater, estimating that it formed between 100 and 500 million years ago. This estimate is supported by evidence that the structure was affected by the Rift Valley, which formed about 100 million years ago during the separation of Antarctica and Australia from the ancient supercontinent Gondwana. This period is particularly notable because it coincides with the Permian-Triassic extinction event, which occurred about 251.9 million years ago and was the largest mass extinction in Earth's history, eliminating 57% of biological families, including 81% of marine species and 70% of terrestrial vertebrates. If the Antarctic Eastern Anomaly is confirmed to be the largest impact crater ever identified, it is possible that the impact played a significant role in the separation of Gondwana. Beneath the Antarctic ice sheet, there are approximately 675 subglacial lakes that have been discovered since the 1990s. The largest of these is the enigmatic Lake Vostok, identified by a team of Russian researchers in the early 1990s. Lake Vostok is a vast body of liquid water located about 4 kilometers beneath the surface of the Antarctic ice, and it is the 6th largest lake in the world by volume. Interestingly, the water in Lake Vostok remains liquid at an average temperature of about -3 degrees Celsius, below freezing, due to geothermal heat supplied from the lake's bed and the pressure from the overlying ice, which lowers the melting point of ice and keeps the water insulated from the extremely cold temperatures above. Although water at -3 degrees Celsius is too cold for many known marine life forms, it is still warm enough for various species adapted to extreme environments to thrive. This suggests the possibility that unknown life forms could exist in the depths of Lake Vostok and other subglacial lakes in Antarctica. Lake Vostok is particularly intriguing because it is believed to have been completely isolated from the external environment due to the Antarctic ice sheet for at least 15 million years. If life exists in the lake, it would have evolved separately from any other life forms on the planet for millions of years. In 2012, a team of Russian scientists successfully drilled through the Antarctic ice sheet to about 4 kilometers depth, collecting water samples from Lake Vostok. However, the initial sample faced substantial criticism due to inadequate sterilization, resulting in heavily contaminated data. Subsequent analyses of the water revealed the presence of kerosene and external bacteria that had contaminated the drill before reaching the lake. To date, researchers have identified 255 known species of contaminating bacteria in the 2012 sample and have also discovered at least one unknown species of bacteria that does not match any entries in international databases. The team hopes this might indicate the presence of at least one new, unidentified microbial life form in the lake's depths. Antarctica is considered a potential site for vast, unexplored natural resources such as oil and gas. In 2024, a Russian expedition discovered an oil field estimated at 511 million barrels in the Weddell Sea. However, oil drilling in Antarctica is currently prohibited by the Antarctic Treaty, which aims to preserve the continent for scientific research and bans the exploitation of natural resources. Signed in 1959, the Antarctic Treaty froze territorial claims from 7 countries, including Argentina, Chile, and the United Kingdom, and prohibited military activities and resource exploitation on the continent. To bolster their territorial claims, Argentina and Chile have established permanent civilian settlements in Antarctica, including sending pregnant women to give birth in the region. Signed in 1959, the Antarctic Treaty froze territorial claims from 7 countries, including Argentina, Chile, and the United Kingdom, and prohibited military activities and resource exploitation on the continent. To bolster their territorial claims, Argentina and Chile have established permanent civilian settlements in Antarctica, including sending pregnant women to give birth in the region. Argentina, the United Kingdom, Chile, and potentially other powers might be incentivized to permit exploration and mining in Antarctica due to the potential for trillion-dollar gains. The oil field in the Weddell Sea is becoming increasingly accessible due to ice melt caused by climate change. However, the location remains remote and challenging, with icebergs and ice flows posing significant obstacles. The economic viability of extraction may change in the near future. If you like this video, subscribe to our channel and turn on notifications.